So we're going to talk about more functions and their graphs. So there are real-world uses of graphs to study data where the data is increasing, decreasing, or constant. So for some examples, there are fuel efficiency of passenger cars from 1955 to 2015, a patient's temperature throughout the day, and the stock market. A function is increasing, decreasing, or constant on an interval if it only increases, if it only decreases, or if it's constant on that open interval. So here you can see the increase where it only goes up, decreasing is only going down, and constant's going to go straight across like a horizontal line. There are local or relative maxima or minima. Those are points at which a function changes its increasing or decreasing behavior. So if the graph is coming down and then it curves and starts to go back up, that's where a min is going to happen, where the curve changes from decreasing and then going to increasing, or if it's increasing and changes to decreasing, that's going to be a maxima. The endpoints cannot be relative maximas or minimums. They have to be in the middle where it's changing its behavior. So for example 1, we are going to use the graph down here to determine the intervals on which the function is increasing, decreasing, constant, find the numbers at which it has a relative max, and what are those, and the relative mins, and what are those. So let's put our example up here. So this is 2.2, and we are looking at example 1. So for part A, we're going to look at our graph here. So here's the graph we're looking at, and we want to find the intervals in which the function is increasing. Now sometimes this is a little misleading because you see the arrow going up, so you think this is an increase, but we look at increasing and decreasing. We start at the left side of the graph and move to the right. So if I'm coming along here and I hit this first, what is the graph doing? Well, as I continue forward, it is decreasing. Even though the arrow points up, it's still a decreasing part right there. Then it's going to increase, decrease, and increase. So for example 1A, and we're looking at part A, where it is increasing, it starts to increase from -3 to 0. You only use the x values on this. We don't look at the y values. We only use the x, and we're only going to use parentheses. So it's from -3 to 0, and this is on increasing. I'll put an INC there. And it starts to decrease again, and then it increases from 3 to infinity. That arrow means it's going on forever, so it will be from 3 to infinity. For part B, we're looking for the decreasing. So decreasing, it starts from -infinity, and it decreases till it gets to -3. Then we increased. Then at 0, it starts to decrease again, and at 0 to 3. Part C is looking for constant. Well, there are no constants on this graph, so it's going to be none. The next part is part D, but let's go back here for just a second. One of the things I want you to notice is all of your domain will be covered through here. So our graph goes from -infinity to infinity because the way that the arrows are, it's going to be the entire real number system for our domain. You can note that it goes from -infinity to -3, -3 to 0, 0 to 3, 3 to infinity. I have not missed any of my sections. So that's one way you can kind of check yourself. Part D, find the numbers at which f has a relative max. So max is going to be the high points where it comes from increasing and goes to decreasing. So this will be our relative max. It happens at 0, and the max is 4. So I'm writing it like that so in case your homework states that, you can understand that. It really is the point of 0, 4. But at 0 is where the maximum happens, and the maximum is equal to 4, in case you find that in your homework. Now, part E is to find the mins. So we have a minimum here where it goes from decreasing to increasing, and one here where it decreases and increases. So those are at -3 and 3, and the min is 0 because they are actually x-intercepts. So you would actually have a -3, 0 and a 3, 0. Those would be the 2 points. All right, so let's look at the graph on part B. So for part A, we again are looking for increasing, B will be our decreasing, and C will be our constant. So looking at increasing, remember we're coming in from the left. As we come to the graph and we go to the right, it is increasing. So it's increasing from -infinity because it's got an arrow, so it's continually going down. And the x value it comes to is -1. And then it doesn't do any more increasing. The graph comes up and then it goes straight across. So there's no decreasing, so there's not going to be none. And where it goes straight across, that's going to be our constant. The constant starts at -1 and it goes to infinity. So again, as I told you in the last graph, we can see that our x values go from -infinity to +infinity, and we can look here in those 3 parts, -infinity to -1, -1 to infinity. We have covered the entire domain. For part D, we're looking for a max. Well, it doesn't increase and then decrease, so there is none. And we're looking for our min. Well, the minimum, again, it would decrease and then increase, and there's none of those. So we won't have a max or min on those graphs. All right, so now we're on to even and odd functions. With even and odd functions, the function f is even if f at -x equals f of x. For all x in the domain of f, every term on the right side does not change its sign. So if you plug in -x, everything keeps the same signs to your function. It will be odd if you plug in -x and you end up getting the opposite of f of x. So that means for all x in the domain of f, every term on the right side changes its sign. Now you can check the exponents to determine if it's even or odd, so you get an idea. But to show it algebraically, you're going to have to use that -x. That's how you're going to figure it out. If you're checking it so that you have an idea of what it should be, all exponents will be odd, it's an odd function. If they're all even, it's an even function. But if some are odd and some are even, then it's neither. Now remember that if you're looking at constants, constants have a variable with an exponent of 0. So it's going to be x to the 0 power. All right, so let's go determine some functions. So this will be example 2. We are going to determine if the function is even, odd, or neither. All right, so part A, if we have f of x is equal to x cubed minus 6x. Now I can look at this function and say, hey, this has a cube, and this would be a degree of 1. They are both odd numbers for my degree, so it should be an odd function. But I actually have to show this algebraically. So I'm going to plug in my -x for each thing. Just like we've done in previous sections, we're going to plug that in for each value of x. So -x cubed, that's -x times -x times -x 3 times. Well, that's going to get me -x cubed. -6 times -x will get me positive 6x. Well, if you notice, how many of the signs changed? Well, the first went from positive to negative. The second one went from negative to positive. Well, this tells me that it did that opposite sign. So when we were looking here, that f at negative x equaled negative f of x. It changed all of the signs, so that's proven that it is odd. So this one will be odd because all signs changed when we plugged in the negative x part. All right, let's look at part B. So if we have g of x is equal to x to the fourth minus 2x squared. Again, I can look at it and go, well, it has a 4 for an exponent and a 2 for an exponent, so I expect it to be an even function. But let's prove it algebraically. So this will be negative x to the fourth minus 2 times negative x squared. Well, negative x to the fourth, well, that's an even number of negatives. It'll be negative x times negative x times negative x times negative x. That will get us positive x to the fourth. Negative x squared, negative x times negative x will be positive x squared times a negative 2 will get us negative 2x squared. So make sure you take care of the exponent before you multiply by the number. Well, if I look, x to the fourth, they were both positive, and then they were both negative 2x squared. Nothing changed. So when I plug this in, I got back the original function. This tells me it is even because no signs changed. I got the g of negative x got me back to g of x. All right, let's look at one more. So part C, we are looking at h of x. H of x is equal to x squared plus 2x plus 1. So if I plug in the negative x, I get negative x squared plus 2 times negative x plus 1. Now, what should I expect to find here? I have an exponent of a 2 and an exponent of a 1. So one is even, one is odd. So I'm expecting this to be a neither. Well, negative x squared will still be a positive x squared. Positive 2 times negative x will get us negative 2x plus 1. Well, this one stayed the same, but this one changed, and this one stayed the same. So some changed and some didn't. So this one will be a neither because some signs change. So be aware of that, of which one is which. All right. So with our graphs, let's talk about symmetry. The symmetry of even and odd functions. It's an even function, the symmetric with respect to the y-axis. If odd function is symmetric with respect to the origin. So let's look at the possible graphs here. So this graph is like symmetric with respect to the y-axis. It is like a mirror image of itself over that y-axis. So that makes it an even function. This one is with respect to the origin. So here's our origin. If I rotate that part around and bring it around this way, you'll see that it actually would lay right over it. So it's reflecting over the origin. Now this one looks similar to this one, but it's not at the origin. And so it is neither. When we're talking about these graphs, they have to actually be exactly the same on either side of it. All right, so the next thing we're going to talk about are piecewise functions. So piecewise functions are defined by two or more equations over a specified domain. That's why they're called piecewise. They come in pieces. One of the more famous ones would be the Fujita scale, which is for tornadoes. So here we have the Fujita scale where it talks about the value will be 1 if the winds are between 40 and 72 miles per hour. The answer will be 2 if it is greater than 72 but up to 112. It'll be a 3 if we're greater than 112 and all the way up to 157. It'll be a F4 if it's 157 all the way up to 206. And then a 5 if it's greater than 206 and up to 260. So that's the way it looks. This would be the graph of it and the way that it's measuring. Here's our wind speed and here's the F scale. So it's basically the same kind of process. We're going to actually look at some functions with it. So let us go look at example 3. So we're going to evaluate a piece function, or a piecewise function. So if we have 4x plus 2 if x is less than 0, and 4x plus 3 if x is greater than or equal to 0. So we're going to look at our piecewise function. So for part A, we're looking at f at negative 2. So if it's negative 2, that's what our x value is negative 2 less than 0 or greater than or equal to 0? Well, negative 2 is less than 0, so because of that, we will use the 4x plus 2. And then we're going to plug in the negative 2 for the x. So 4 times negative 2 plus 2, that'll get you negative 8 plus 2, which will be negative 6. Okay, for part B, we're looking at f at 0. Well, this is less than 0. This is greater than or equal to 0. So we will use this one. So we're going to use the 4x plus 3. So 4 times 0 plus 3, because you're always plugging in what your x value is. Well, 4 times 0 is 0 plus 3. We'll end up with 3. And then part C, if we're looking for f at 3, well, 3 is greater than or equal to 0. So again, we'll use the 4x plus 3. So we'll have 4 times 3 plus 3, which will get us 12 plus 3, which will be 15. All right. So we are going to do a couple of things for the next problem. So here is example 4. And we are given f of x equal to 3x if x is less than or equal to 0, and 2 if x is greater than 0. First of all, we want to graph the function, and then we want to use the graph to determine the range. So for part B, we want to find the range. All right, so to graph it, we're going to have to actually graph each part. So we're going to make a t-chart, and that'll be our x and our y. So for the first part, we're looking for x's less than or equal to 0. So we need to include 0 because we're equal to 0 part here, and we need to have some values that are less than 0. So I'm going to pick like negative 2 and negative 4. I try to spread them out a little bit so we can see what's happening. Well, if I plug in 0, I get 3 times 0. Well, that's 0. This would be 3 times negative 2, which would be negative 6, and 3 times negative 4, which would get me negative 12. On this half, we're going to do another t-chart for x and y. And it's 2 if x is greater than or equal to 0. So let's go with like 2, 4, and 6. So if I have 2, well, the answer is 2. If I have 4, the answer is 2. If I pick 6, the answer is 2. So no matter what, your answer will be 2 for your y value. So let's go ahead and graph this. I probably won't go clear to the negative 12 on the y because I can plot it with the 2 points. So I need to go to at least 6, and I need to go to 6 there. So x and y, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so to graph this one, I'm going to graph at 0, 0. Well, that's my origin. And it includes that one. And then negative 2, negative 6. So negative 2 down to 1, 2, 3, 4, 5, 6, over to negative 2. And this part is going to be a solid line going down with that closed circle there. The next one is going to be at 2, 2. So right here, at 4, 2, and at 6, 2. But we also have to understand that it would go at 1, 2, and at 0, it's going to map here, but all the way up to 0. So we're going to make an open circle here and then draw our line that way. So that would be what our graph looks like. Now, if we're looking for the range, we're looking that it comes all the way up from negative infinity to 0. So it'll be negative infinity to 0. And then it picks up at 0, but it only goes to 2. So we'll be union with 2. And that is a curve. Started writing like the negative part. So negative infinity to 0 with a parenthesis and a bracket here, union with the singleton set of 2. All right, next we have a cell phone problem. Wink, wink, nudge, nudge. You should learn how to do this. All right, so we have a cell phone problem. Our company offers the following plan. $20 per month includes 60 free minutes. Additional time costs 40 cents per minute. Write a function C to represent the monthly cost where X is the number of minutes used. Find C at 30 and C at 100. So this will be example 5. All right, so there's a couple of key things that are happening there. First of all, it's $20 a month no matter what. And we are setting up a piecewise function for this. So we have C of X is equal to, and we have 2 parts. It's $20 no matter how many minutes you used. It's $20 a month, and it includes 60 free minutes. Any additional time after 60 means you have to pay 40 cents a minute. So you still have to pay the $20 monthly fee, whether you use the phone or not. And we'll pay 40 cents a minute, anything that is above 60. So we need to subtract the 60 minutes from however minutes we use. Now, if we go under 60, we'll just use this one. Now, we need to put our stipulations of if. So this part will be if our minutes are between 0 and 60. And this one will be if we go greater than 60. So as long as we stay within 60 minutes, it's only $20. If you go above 60, then we're going to have to pay 40 cents for each of those. And you want to make sure you do the minus 60 because you don't want to pay for the 60 minutes you get for free. Now it asks us to do C at 30. Well, where does 30 land? 30 lands between 0 and 60, so it's just going to be the $20. Now we also need to find C at 100. Well, 100 is greater than 60, so we'll use the second part. So we'll have 20 plus 0.40. This is x minus 60. Our x will now be 100. So 100 minus 60. So that's 20 plus 0.40 times 40, because 100 minus 60 will get us 40. So that's 20 plus 40 times 40 cents would be 16, which will get us 36. Now you can simplify this part here if they ask you to. Just go ahead and distribute the 40 cents and you can simplify it, but anything that I ask you to do, you can just leave it like that because you're going to be plugging it in anyway, so it'll be fine. Just to do this if you're doing it on a test question. All right, the last thing we have is the difference quotient. It is f of x plus h minus f of x over h, where h cannot be equal to 0 because we can't divide by 0. So we're going to evaluate one of these functions. So this will be example 6. And we are going to evaluate and simplify. A difference quotient. And we are looking at f of x is equal to 2x squared minus x plus 3. Remember the formula is f of x plus h minus f of x all over h. H can't be equal to 0. So the first thing we want to do is we're going to do this in parts and then we'll put it back together. We need to find f of x plus h. So remember, this is just like anything else we've done where we plugged in -2, we plugged in 3, we plugged in -x. This time we're plugging in x plus h. So wherever our x is becomes x plus h. So 2 times x plus h squared minus x plus h plus 3. Make sure you use parentheses. So we have to kind of FOIL this out. So I'm going to bring that over here. X plus h squared is x plus h times x plus h. It is not x squared plus h squared, so make sure you FOIL it. So again, x times x will get us x squared. X times h will get us plus xh. H times x, you can still write it as xh, or hx is multiplication, doesn't matter. H times h is h squared. These two are going to combine, so we'll get x squared plus 2xh plus h squared. So we'll go plug this in over here. So we have 2 times x squared plus 2xh plus h squared. You still have to multiply by 2 because that's still part of it. Minus our x plus h. So we can distribute the negative x minus h plus 3. So let's multiply by 2. So that's 2x squared plus 4xh plus 2h squared minus x minus h plus 3. None of these are like terms, so we can't combine them. So now we're going to take this and plug it into the entire formula. So we need to find our f of x plus h minus our f of x all over h. The first part is 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now from that we have to subtract the entire original formula, which is 2x squared minus x plus 3, and divide the whole thing by h. So this is the f of x plus h we found minus the original formula of f of x all over h. So the first thing we'll do is distribute our negative sign. So 2x squared plus 4xh plus 2h squared minus x minus h plus 3 minus 2x squared minus, negative times a negative positive x minus 3 all over h. So now you look for things that will cancel. Everything should cancel unless it has an h in it. So 2x squared minus 2x squared, those will cancel. That's an xh, there's an h squared. We have a negative x and a positive x. And we have a positive 3 and a negative 3. The only thing we should have left should have an h in it. So 4xh plus 2h squared minus h all over h. Now, up in the top, they all have an h in common. So h times 4x plus 2h, because we're only taking out one h, minus 1. You have to put the 1 as a placeholder. All over h. The h's will cancel, and you end up with 4x plus 2h minus 1, and that would be your final answer. And that's how you evaluate and simplify the difference quotient.